In the last lesson, we looked at how we can launch a thread. Now let's go ahead and implement it. So apart from that, apart from implementing it, we will also look at an alternative way to launch a thread. Okay, so there's a second way to do it and we will also look at that. And then we will see how we can put a thread to sleep. We said that we can invoke the sleep method for doing that, and we will also look at that. Okay, so for this demo, I added a new package called com.semanticsquare.concurrency, and we are going to add our classes within this package. So the first class is called as my first thread, since this is going to be our first thread. So here is the template and we are going to fill it now. So let's just go ahead and create a thread. So for creating a thread, we need a task. Okay, so let's create a task. Basically, we need to create a runnable object. Let's just call it as task. Okay, so this is a class. So let's just go ahead and create a class here called task. Now task has to implement runnable. We know that. Okay. Now we know that the runnable has a method called run, right? So we need to implement that. We need to override that method. So here it is. Now here, let's put a system.out statement, sysout control space, and let's say inside run. So the real business logic of the task goes here, of the thread actually goes here in the run method, and from the run method we can actually invoke other methods. So let's also go ahead and invoke some other methods. So let's write a method called go. Okay, so it's a private method. So once again, I just copy this. This is inside go. And let's add one more method called more. So basically this is our task. The run method is here and it is invoking go, and go is in turn invoking more. So the hope is that I wanted to show you the way the thread scheduler behaves. So these multiple invocations is for that. And let's just hope that the thread scheduler would help us in seeing the sequence of events. So we will test it out. But here we have the main method. Now we created the task. Next step is to create the thread. So we simply need to instantiate that. Let's say thread. And we need to pass the task. So thread is the worker and task is the work. Now we are in the new state, right? The next step is to start the thread, and nothing happens until we do that. Okay, so that's how we start the thread. And let's also put a system.out statement here. And that's it. So at this instance, if we run JVM, there will be two threads. One is the main thread, which the JVM creates in order to run the main method itself. So that would be this thread. But then here we are also creating a second thread. Okay, so there are two threads which will run when we run this program, and both of them are non-daemon threads, and JVM will not terminate until both the threads are done with their execution. Okay, so let's go ahead and run it. So what is happening here is the thread scheduler is first running the main thread to completion, and then it is running the second thread. Let's call it as the second thread. And it is running that to completion. Okay, so the inside run is getting invoked, and then go, and then more. Now let's keep running until we can see the switching between the two threads. Okay, now here you can see that this time the second thread has been launched first. Okay, so we are inside run. So the second thread is in running state. Then the thread scheduler is sending it to runnable state, so that it can bring the main thread into running state. Okay, so the second thread has been sent into runnable state, and the main thread now is in running state. But then after the main thread has been run to completion, then the second thread will go back to the running state. That's what the thread scheduler is doing. And then it continues executing the remaining part of the second thread, which is to invoke go and which is to invoke more. Okay, So we can see that the thread scheduler is not behaving consistently. Okay, so there is no guarantee on how it works, and so we should never ever rely on it for our program's correctness. Okay, so that's the thread scheduler. And now let's look at the second approach. So for that, I already created this class called myThread2. Okay, so this is the alternative way to launch a thread. And here there is no runnable. Runnable is there, but the thing is, the thread class itself, even though the thread class itself actually implements runnable interface. Okay, so in this approach, the task will be defined within the thread class itself. Okay, so I said that the thread class is also implementing the runnable interface, which means that thread also has the run method, and it does have the run method, but that run method does not do anything. It's pretty much like an empty method. You can look at the source code too. It has something, it does something, but there is nothing happening there. So what we need to do is we need to extend that thread. So my first thread 2 is extending it, which means that my first thread 2 is also a thread, but it is going to override the run method in the thread class. And that's what we are doing here. And the run method is once again invoking Go, and Go is invoking more. So it's just the same code that we had in the task class. Okay, it has been moved into this class. Okay, so that's all it is. And here in the main method, we are simply instantiating it, and we are invoking the start method here. Okay, so let me just run this once again. So here you go. It's just the same output. So the question would be, which method should we prefer? Should we go with the first approach or the second approach? And the suggestion is to go with the first approach, and that's what you should do. The reason is, so here we have the worker, which is the thread, and its work, which is the task. So these are two different activities, right? And from a good object-oriented design standpoint, if there are such activities, different activities, then they should be represented by different classes. Okay, so that we'll have loosely coupled design. Okay, and it will have its own benefits. And that's the reason why you should go with this, with the first approach. In the second approach, that's not the case. Both the activities have been intermingled. So it is tightly coupled, and that's not a good design from an object-oriented standpoint. And that is what is recommended to go with the first approach. Okay, so if you look at Stack Overflow or anywhere, you will see that this approach is recommended. So that's the second alternative. Now let's just go ahead and see how we can put a thread to sleep. For that, we just need to invoke the sleep method. So the sleep method is a static method in the thread class. So let's just put the sleep statement here. Here it is. Now the sleep method is a static method, but it throws an checked exception called interrupted exception. We will look at it later. But since it's a checked exception, we need to handle it via a try catch statement, and let's do that. So here it is. Interrupted exception will be discussed later, but this is what we are doing. So we are invoking the sleep method, and the sleep method accepts, it has a single parameter which is long. By doing this, we are saying that the current thread, which is the main thread, has to sleep for so many milliseconds, 3000 milliseconds, which is nothing but 3 seconds. Okay, so with this statement, the current thread would stop its execution, would cease its execution for this many milliseconds, for 3000 milliseconds. Okay, so that's what we are doing. So let's go ahead and execute it. Now you can see that the program is still running. Okay, and now it has ended after 3 seconds. So in this case, the second thread has run to completion, and after 3 seconds, the main thread has also run to completion. Okay, so basically that's what the sleep statement does, the sleep invocation does. Now the question would be, why would you need such a sleep statement? So one example I can think of is the web crawler example. We discussed it at the beginning of the chapter. A web crawler is simply a software that search engine uses to crawl the web. And the way crawling works is, let's say if you give a particular link, a URL to a web crawler, then what it does is it's going to download the corresponding web page, and then that web page has some number of links. So it's going to download all of those links, and each of those links is basically a web page, and those web pages also have links, then it's going to download all of those links also, and the process continues, and that's how a web crawler works. Now, if a particular web page has some number of links, and all of those links, or at least the majority of them, are pointing to one particular site. Okay, different pages in one particular site. So the crawler is going to download all those pages, and the problem with that is it's going to send requests, HTTP requests for all of those links, and that could place burden on the web server that is hosting those pages. Okay, so web server can accept only so many requests in a given time. So you should not overburden the server. You should make sure that you are not hitting it too hard. So what you can do is, between two successive requests, you can insert some delay. Okay, so if your downloading task is done by a thread, then between two successive requests, you can insert a gap, and that you can do using this sleep. So let's say if you have sent a request to the server to download a page, and after doing that, you can wait for 1 second. 1 second is a good delay. After that, you can download the second page. Okay, so it is good for inserting delays. And the second example could be to run some background jobs on your server periodically. Okay, so let's say you have done something. Let's say you have sent an email today at 8 p.m. and then you would do it after 1 hour. Let's say you are going to send another marketing email. So if a thread is doing that, so once it sends the email, you can make the thread sleep for an hour, and after that the sleep will wake up, and then it will send the next campaign emails. So you can do that, but in general, such kind of scheduling of jobs can be taken care of in a much better way using frameworks like Spring. Spring has some sub-components. One of them is called as Quartz Scheduler. It can be used for that. So we don't have to do this, but if you really want to do that, so that's the way you can do it. Use the sleep method. Okay, so that's the thing. Now there is also a second way to insert sleep. That is, there is this enum called time unit, and here it has different ways of doing it. Now the disadvantage with the sleep method here is the unit of time is only milliseconds. So if you want to wait for, let's say, an hour, then you need to convert that into milliseconds and pass it as the argument, which is not very convenient. So that's why in Java 5 they have introduced this time unit enum class, and time unit has different units of time here, like days, hours, microseconds, milliseconds, and let's add seconds too. Let's just select seconds here, and let's put 3. Actually, we need to say .sleep of 3. Okay, that's it. And now the main thread is waiting for 3 seconds, and it is done. So this is another way to do it, a slightly more convenient and a readable way to do it. So that's the time unit. It's an enum. Now that's about it. And one more thing is, so we looked at the two approaches for launching a thread, and we looked at sleep method. And one last thing is, so let's say that this thread has run to completion. So its run method has been completely executed. So the question is, can we restart the thread by just saying thread.start? And that's not possible, because once the run method finishes its execution, it goes into a state called dead. Okay, so at that point, this thread instance will still be on the heap, but it's just a useless object, just like any regular object. So there is it's in the dead state now. So even if you try to do it, it will throw an exception. So let's just do that. So as you can see, it says illegal thread state exception. So you can never do that. So once the thread finishes its execution, that is, the run method has been executed completely, then it goes into dead state. Okay, so it's the new state and then the dead state, and then we also have runnable, running, and the blocked state. Okay, and that's about it. Thank you and happy coding.